Okay, let us start our lecture. So, am I audible? Am I audible?
Yes, sir.
Okay, okay, okay.
Yes, sir.
Okay. So, in our previous class, we have discussed about the basic of geometric design and what about the different components of the geometric design. So, from our previous class, we get to know about different components like side distance, horizontal curves, okay, vertical curves, gradient, etc. So, in this class, we particularly discuss about the basic of the side distance and uh, what are the derivation in side distance regulations. Okay, now side distance, as we have already discussed many times, that side distance is the distance visible ahead of a driver. Okay, so the actual distance along the road surface which a driver from a specific height above the carriageway has a visibility of a stationary or moving object is known as sight distance. Now here one thing you can notice in the definition, which a driver from a specified height. Okay, so in the sight distance definition, there is defined as a specified height. So what is the specified height? So generally, as per Indian Road Congress, the eyesight of the driver is considered to be at an elevation of 1.2 meter above the carriageway. Okay, so that is basically specified height. Now, has a visibility of stationary or moving object. Now, this stationary or moving object, the height of the stationary and moving object is also fixed by Indian Road Congress, and that is considered as 0.15 meter. Okay, so it is sight distance. It is called sight distance. Now, there are different types of sight distance. The most important one is stopping sight distance. And as the stopping sight distance is required in each and every portion of the road, therefore this sight distance is called absolute minimum sight distance. Absolute minimum sight distance means whether any other sight distance for the land purpose or for any other constraint, if any other type of sight distance cannot be provided over a particular section, but you must have to provide stopping sight distance over there. This is must. Okay, so therefore it is called absolute minimum sight distance. Now coming to the next portion, intermediate sight distance. Intermediate sight distance is defined as twice as the sight distance. Then coming the next, overtaking sight distance. Now this overtaking sight distance is required for the overtaking operation of the vehicle. Then headlight sight distance. This is again is calculated on the basis of stopping sight distance and safe sight distance to enter into an intersection, because in the intersection there are three or four roads coming together. Okay, and sometimes the view of the drivers are hindered or blocked due to the nearby building and other structures. So there also, for the safe operation of the vehicle, a minimum sight distance is required. Now, the competition of the sight distance, this depends on various factors, and this restriction to the sight distance, why sight distance is restricted, is caused by different factors. Like for this one, this is a horizontal curve. So whenever a vehicle is over there, that is when he enters a horizontal curve, in that case, up to this portion, he can be, it is visible. Okay, but whenever he is over there at the midpoint of the intersection, in that case, whatever vehicle is coming in that portion is not visible. Okay, Now suppose if this is the eyesight of the driver, suppose here some permanent structure is there. So in that case, what will happen? The eyesight of the driver will be blocked by some obstruction. Okay, so what happens in the horizontal curve? Always you need to find out this distance, that up to which a building or any construction cannot be built, so that the eyesight of the driver cannot be blocked, and this particular distance is called setback distance. So we'll discuss this later on about the setback distance. So in the horizontal curve, this obstruction may causes the side distance. Now in the vertical curves, see in the vertical curves also, suppose this vehicle is there, because of the vertical curve, okay, the side distance of the driver may block. Okay, then side distances at intersection. C. This is an intersection. There are different vehicles coming from different direction. Now, suppose here some building or some structures is there. So for that reason also the eyesight of the driver may be blocked. Now coming to our next portion, stopping sight distance. So stopping sight distance, as the name suggests, it is the sight distance required to stop a vehicle. Okay, now let us go with the definition. Just a minute. Uh, the minimum sight distance available on a highway to stop a vehicle traveling at a design speed, just remember this term, design speed, safely without collision with any other obstruction, is called stopping sight distance. So stopping sight distance is, suppose a vehicle is moving in the road with a particular design speed. Okay, and the stopping sight distance is a particular distance which a driver had the visibility to stop the vehicle before colliding with other obstruction. Now, for the design purpose, IRCS suggested to consider the object height as 0.15 meter, as we have discussed earlier, and height of the driver eye is at 1.2 meter. Now, there are different factors which affect the stopping sight distance. So, first one is reaction time of the driver. Now, let us discuss what is this reaction time. Let us discuss with some figure. Okay, suppose this is an obstruction. This is an obstruction, and a driver is moving in this vehicle. So suppose whenever he sees this obstruction, in that case, first thing is he will analyze the situation. Okay, he will analyze the situation, whether he should stop the vehicle or whether he can easily get past to the obstruction. So this particular time, whenever the driver thinks about the situation, that particular time is called a reaction time. So reaction time of a driver is a time taken from the instant the object is visible to the driver to the instant when the brakes are applied. So during the reaction time, the driver will think about the situation. Okay, he will analyze the situation, and after analyzing, he may apply the brake to stop the vehicle, or he can pass through other lanes. Okay, so basically the reaction time is the very important thing. Now, many of the studies shows that drivers require about 1.5 to 2 seconds under normal condition for react to something which is happening over road. Now, however, for the safety purpose or for taking consideration for the design purpose, normally IRC has considered a reaction time of 2.5 seconds. So whenever you are designing that stopping sight distance, you will consider the reaction time as 2.5 seconds. So the next thing which is important, that is speed of the vehicles. Now speed of the vehicles is very much important, because if your speed is higher, in that case your application of the brake should also be higher, and your braking distance means after the application of the brake, how much distance that vehicle has traveled, that is called your braking distance. Now the speed of the vehicle very much affect the sight distance. Higher the speed, more time will be required to stop vehicle. Hence, it is evident that as the speed increases, sight distance also increases. So, for your sight distance, next important factor is speed of the vehicle. So, as the stopping sight distance will depend on the speed of the vehicles too. Then coming to the next portion, efficiency of brake, that how much efficient the brakes are. Now the efficiency of the brakes depends upon the age of the vehicle characteristics, and the braking mechanism of the vehicle. Now if the brake efficiency is 100%, the vehicle will stop the moment the brakes are applied. But in actual field, what happens, the brake efficiency is not 100%. So for that reason, whenever you apply some brake, apply the brakes, that your vehicle do not stop immediately, but it will go a particular distance, and after traveling that particular distance, it will gradually stop. Therefore, the sight distance required will be more when the efficiency of the brakes are less, and whenever the efficiency of the brakes is more, in that case, sight distance would be less. So, for the safe geometry design, we assume that vehicles have only 50% of the brake efficiency. Now, next thing is frictional resistance between the tire and the road. Now, this frictional resistance is also important, because if there is not adequate frictional resistance, in that case, what will happen, whenever the brakes are applied, the vehicle will not stop immediately or not stop after a considerable portion of the distance. Now, the frictional resistance between the tire and the road plays an important role. When the frictional resistance is more, the vehicle stops immediately, and whenever it is less, then the distance required for the vehicle for stopping is very much higher, will be very much higher. Now, this frictional resistance is taken into consideration in terms of coefficient of friction value, and IRC has specified the value of the longitudinal friction in between 0.35 to 0.4, depending on the speed of the vehicles. Okay, so the value of the longitudinal coefficient of friction value depends on the speed of the vehicles, and its value ranges from 0.35 to 0.4. Now remember one thing, whenever you are designing for the side distance, in that case the coefficient of friction which is required, that is longitudinal coefficient of friction. Now whenever you will be designing your horizontal curves, in that case the side distance, the coefficient of the friction would be lateral coefficient of friction. So remember this thing, don't confuse about longitudinal friction and lateral friction. So in this case we only consider the longitudinal friction. Now coming to the next portion, gradient of the road. Now, gradient of the road also affects the sight distance. Now, while climbing up a gradient, the vehicle can stop immediately, because that gravitational force of the earth will act in this favor, in the favor of the brakes. And whenever a vehicle climbing down a gradient, in that case the distance required for the vehicle to stop the vehicle would be very much higher than the previous case, so that also affect the sight distance. Now whenever we are talking about the reaction time, that is how the reaction time will taken about and what are the different component of the reaction time. In that case there are different theories. Scientists has given different theories on the reaction time of the driver. Okay, so basically that reaction time will be depending on the driver behavior, but among them, the most important theory is PIEV theory, where P stands for perception time, I stand for intellection time, E stands for emotion time, and V for volition time. Now, what are these? Okay, let us discuss about this. So, perception time, it is the time required for the sensation received by the eyes or ears to be transmitted to the brain through the nervous system. So, what does this indicate? So, like as of our previous example, suppose this is the obstruction. Okay, so whenever you see this obstruction, so what will happen? We have receptors in terms of our eyes, nose, or skin, like that. So we see this object. After seeing this object, what will happen? Some reception or some sensation will pass through our nervous system from our eyes to our brain. Okay, so that time is actually perception time. So during this perception time you perceive the situation. Okay, like this thing, suppose you have observed something, so after observing some signal will pass to your brain now. After that signal passing, the signal will processed in the brain. So that time when the signal is passes through the brain, that time is called perception time. Suppose this is your brain and this is the nervous system which connects your stimulus to the brain. In that case, this time requirement for the signal to pass in your brain or reach in your brain is called your perception time. Now, intellection time. So, what is intellection time? Intellection time is basically the time required for understanding the situation. Understanding situation means after you receive the signal in your brain, in that case, what will happen? The brain will decide upon various things. Okay, it will decide what to do or what not to do, and what is the object, what is the size of the object. Okay, what may be the possible distance of the object, so different calculation will be carried on in your brain. So that time is called intellection time. Okay, so after the signal reach to your brain, in that case brain will analyze the situation. Okay, so that is the time that is called intellection time. Then emotion time. So emotion time, that is also happening in your brain only. Emotion time, it is the time elapsed during emotional sensation and disturbance such as fear, anger, etc. So suppose your mind is full of some fear or some other thoughts. Okay, in that case what will happen? You will take much more time than the normal condition to understand the situation. Okay, so that is called emotion time. So for this reason only, the drinking and driving, that was not allowed, because whenever a driver drinks, in that case, he cannot think properly. Okay, his normal reaction time will be get enhanced. It will increase. So in that case, he cannot uh, uh, analyze the situation. Okay, so for that reason, that emotion time is also an important thing. So that emotion time is also happening in the brain, and this is also happening side by side with the intellection time. After that, volitation time. So in that case what will happen? So in the intellection time and emotional time, within that time the brain will decide what to do. Okay, whether you need to stop the vehicle or that object is far or you can overcome this. Okay, so after taking the decision, you have taken the decision, again you will send some sensation with the nervous system to the different organs or different portion of our body, like our hands or legs, to apply the brakes or to pass in the other direction. So that time is called basically volition time. Okay, so PIV theory, is it clear? See, it is very important theory, so there should not be any confusion. Is it clear to all of you? Okay. See, this theory is very much important. So if you have any confusion regarding this theory, you can just post your comment in the chat box, or you can directly ask me. So I suppose this is very much clear to you. Let us move on. Now come to the next portion, that is analysis of the SSD. That is how you derive the equation for the side distance. Okay, so as you know, the side distance. Okay, there is a term called safe stopping distance, and it is one of the important measures of the traffic engineering. So it is the distance a vehicle travels from the point at which a situation is first perceived to the time the deceleration is complete. So you take some decision. After taking the decision, you apply some brake. After the application of the brake, the vehicle will decelerate and ultimately it will stop. Okay, now drivers must have adequate time if they are suddenly responding to a situation. Now, thus, in highway design, sight distance at least equal to the safe stopping distance should be provided. That's why it is called absolute minimum sight distance. Now, you know, as in the for the sight distance, first the driver have to think about the situation within the reaction time. Okay, so within that reaction time, the vehicle will move forward with the design speed. Okay, that is called lag distance or reaction distance. That is distance traveled by the vehicle within the reaction time. So after the reaction time, the driver will analyze the situation and apply the brake. But what happens, because of the braking efficiency and coefficient of frictions and other factors, the vehicle will not stop immediately after application of the brake. Suppose here, after the ending of the reaction time, you apply the brake, and during the reaction time, you have analyzed the situation and you just decide to apply the brake. So after the application of the brake, what will happen? The vehicle will start to lose its speed and it decelerate, and after a certain distance, it will stop. Okay, so now this distance, that whenever you apply the brake and after the car stopped, that particular distance is called braking distance. So your side distance is of two part. First one is lag distance or reaction distance, and second one is braking distance. Now let us discuss about the lag distance. So the distance traveled by the vehicle during the total reaction time is known as lag distance. Now coming to the derivation portion, suppose v is the velocity of the vehicle in meter per second. Okay, v is the velocity of the vehicle in meter per second, and suppose the reaction time is t. So the lag distance is the distance traveled during this reaction time, and it would be given by v into t. So this is very simple. Suppose you're in that distance, it is considered that during the reaction time the vehicle will operate in a design speed. Okay, and that speed is constant speed. So the distance, total distance traveled by the driver would be the speed of the vehicle into total time. Okay, that is total reaction time. So if it is v meter per second, the speed of the vehicle, in that case if t is the reaction time, then the total distance covered by the vehicle during the reaction time would be v into t. Now coming to the next portion, that braking distance, how we will calculate the braking distance. So braking distance is the distance traveled by the vehicle during the braking operation. Okay, now whenever the vehicle is moving, in that case for a level road, this is obtained by equating the work done in stopping the vehicle and the kinetic energy of the vehicle. So whenever this vehicle is moving, in that case there is some kinetic energy to be there. Now after the application of the brake, the vehicle will also stop. So you are applied some force on the vehicle to do some work in terms of stopping the vehicle. So here some work done will be associated. So if F is the maximum frictional force developed and the braking distance is L, suppose this braking distance is L, then work done against friction in stopping the vehicle is F into L. That is, F is your frictional force. That frictional force is applied to stop the vehicle, okay, with a distance of L. So you know your work done is force into distance. So force into L, that is the distance, that is work done by the vehicle after the application of the brake. Now F, that is the frictional force, it can be written as coefficient of the friction into weight of the vehicle. Okay, where W is the total weight of the vehicle and F is the coefficient of longitudinal friction. Now the kinetic energy. Let us discuss about the kinetic energy. The kinetic energy at the design speed would be half into mv square. Okay, so you can write this in this way because m is nothing but weight of the vehicle divided by gravitational acceleration. So half w v square by g. Now whenever you apply the brake for stopping the vehicle, that work done should be equal to the kinetic energy of the vehicle to stop it. So thereafter you can say that your work done is equal to that kinetic energy of the vehicle. So from that equation you find out your L. Okay, that is the braking distance. So your braking distance is v square divided by 2gl. Here one thing you just remember, that here all this unit, that is v is in meter per second. So therefore SHD is lag distance plus braking distance, and it is given by SHD equal to vt. Vt was your reaction distance or lag distance plus v square divided by 2gf. Okay, so this is your equation for the SHD. Now you also know that gradient also plays an important role in the stopping side distance. So when there is an ascending gradient, okay, ascending means you are going upward, of say plus n percent. N percent means n is vertical and 100 is horizontal. So for each 100 horizontal, it may be in meter or kilometer, there will be an vertical. The component of gravity adds to braking action, hence braking distance is decreased. Okay. Now the component of gravity acting parallel to the surface which adds to the braking force is equal to W sine alpha. So this is uh, W sine alpha, and as your this n, okay, that is your elevation is very much slower or very much lower. In that case, sine alpha can be equivalent to tan alpha. So you can write W sine alpha equal to W tan alpha, and tan alpha is nothing but that n divided by 100. So basically it is not required, just you go for the final equation. Your final equation for the ascending gradient would be L is v square divided by 2g f plus n percent or n by 100. Okay, so here you add up this thing, so ultimately this braking distance would be lesser. Okay, just remember this thing. Whenever that is a ascending gradient, you add up some factor in terms of the slope of that the gradient, so that the braking distance ultimately got lower. Okay, and whenever you are traveling in a descending gradient, in that case it would be negative. Okay, so ultimately your SHD would be v square divided by 2g f plus minus 0.01 into f. So plus is for the ascending gradient and minus is for the descending gradient. So is it clear? Is it clear to all of you? Okay. So if it is clear, now next class we'll solve some numericals. You will solve some numericals. So give your attendance. I'll just write it down, and after that you just leave the meeting, and after 10 minutes you just rejoin the meeting. Okay, with that in the same link. I think you have another class from 1 p.m. now. So we'll just continue this class, and in your next class, that would be like 11:40 from 12. So in your next class, you just be with some pen and paper.